What is the meaning of the first derivative? Everyone learns in class that the derivative of a function somehow measures the rate of change of that function. But how does this work exactly? That's coming up right now. Consider an arbitrary function of a single variable. And let's ask ourselves a question. What is the rate of change of this function at a particular point? Right away, there is a problem with this question, and it's the following. If we want to know the rate of change of a function, we need to evaluate the function at least 2 points, right? That's the very meaning of a change. For example, if I tell you that my speed is now 100 km per hour, that alone tells you nothing about my speed a second or 10 seconds later. It could be higher, lower, or exactly the same. So we definitely need a second point in order to capture how fast the function is changing. Next, we plot the secant line that intersects these 2 points. Any straight line can be described by a linear function of this form. The key idea here is the slope of a secant line. The larger the slope, the greater the change in the function. In our case, the function for the secant line looks like this, and its slope is given by the following formula. But the slope of a secant line isn't exactly what we are looking for, because it only captures the average rate of change between 2 points. Consider this function. The slope of the secant line between 2 specific points is 0, meaning that on average the function didn't change. But in reality it may have done all kinds of things in between. Things that the slope of a secant line can possibly capture. What we really want is something that measures the instantaneous rate of change at a single point. That might sound paradoxical, since change usually means comparing 2 points, while instantaneous refers to just one. So how can we talk about the rate of change at a single point? There is an elegant way around this, and it involves the concept of a limit from calculus. So what do we do next? We take a limiting value of the secant line as b approaches a, and look what we get. Here is the well-known definition of the derivative of a function at point A. Geometrically, this means that as b approaches a, the secant line becomes the tangent line, and the slope of the tangent line is the derivative of the function at that point. So there you have it. The instantaneous rate of change of a function at a specific point is captured by the slope of the tangent line at that point, and that's the meaning of the first derivative.